Okay, welcome to the video on Chapter 1, Section 3, and we'll be talking about circles in this video. So the first thing we want to give is just a brief definition of what a circle is. And a circle is a closed shape where all points are equidistant from the center of that shape. So I know that sounds a little confusing, but let's just draw it out and take a look. Let's say I have a point here, and that's point Q, okay? And we want to draw circle Q. So we'd call circle Q, put a dot in the center and call that Q. That's would be circle Q. But how would we go about drawing a circle? Well, you probably know what a circle looks like. You could just draw this, rounded shape around here. But really what a circle is, if I were to draw 1 inch from here and say that that length is 1 inch. 1 inch, okay? And then I dropped a point here and called that T. And then I did the same thing over here. And I drew 1 inch away down this way, and that's 1 inch. And then I did the same thing an infinite amount of times all the way around the circle. I'd get a bunch of points that are 1 inch away from point Q, right? 1 inch, 1 inch, 1 inch, 1 inch, all when they hit the side of this shape that I've drawn, all those lengths will be 1 inch, right? I can do the same thing on the other side. That was bad. So like 1 inch, 1 inch, 1 inch, and you connect all these, you get something that looks like that, right? Now this is what a circle is. It's where all points along the side of the circle here are equidistant, meaning have the same distance to the center, which is Q. The center is Q, a point is T. So now we have this segment TQ, right? We have segment TQ. Well, what's the length of segment TQ? Well, we know that that's 1 inch, right? We also know that that's something called a radius. A radius is the distance from the center of the circle to the side, any point on the side. So all these lines that I've drawn here are radii, they're radiuses, and they all have a length of 1 inch. So the radius of this circle would be, would be 1 inch, right? 1 inch, 1 in. Now, there's also another type of line in a circle you'll encounter, and that's something like this, or like this, if you're following here. Let me use a different color. Like this straight down, or like this straight down, or like this straight down, right? Through the center of Q. So when I connect 2 points on a circle, let's say I connect point T and point R down here. If I connect point T and R, and I pass through the center of the circle Q, then segment TR is called a diameter. Well, really, what's the length of segment TR? Well, we know that it's made up of 2 radii. It's made up of segment TQ, which is a radius, and we know the radius is 1 inch. We know it's made up of segment QR, which is a radius. So really it's 1 plus 1, which is equal to 2 inches. That's the diameter of this circle. Now there's another type of line that we've already kind of talked about with diameter, which is called a chord. And a chord is any segment that starts on one point of the circle and hits another point of the circle, but it doesn't necessarily pass through the center. So this right here, this red line that I've drawn is a chord. Let's say XY. So XY segment is a chord, and that's how you write chord. So chord, and you can find chord lengths using various methods. So a diameter is simply a special type of chord. Not every chord is a diameter, but every diameter is a chord. So a chord that passes through the center of the circle is a diameter. Now another type of line is a secant. That's kind of like a chord. It's a line, not a segment. It'll pass through 2 points of the circle and keep going on either direction, or it'll be a ray. It'll be fixed here and keep going in that direction. And that's a secant line, and that can be at anywhere. That could be up here, that could be over here. Now the final line I want to talk to you about is something called a tangent. Tangent, tange or tangible, tange means touch, to touch. And so a tangent line simply touches the circle on one spot. And well, can you think of a line that touches the circle in one spot? Well, it couldn't go through the circle, right? That's what I'm trying to say. It couldn't go through the circle, right? Because it has to hit both sides. So it would pass, a tangent would look something like this. They look similar to this secant right here, but it will look something like that, right? And it'll keep going on either direction. That's a tangent line, and it hits at one spot right there. Now, something interesting you'll learn in later chapters is if I have this tangent line here, and then I have this radius right here to the center, when those two touch at that point on the circle, let's call it Z, it always forms a right angle. They always form a right angle with each other, and that'll come in handy when we get into other stuff, but you don't need to worry about it now. So for right now, I'm just going to write touch. Oops. Touch, right? And always in one spot, okay? And so that's important to realize about tangent lines. Now, there aren't many other aspects of a circle that we need to discuss. Now, the only thing I will give you insight into before we go through and move on to higher level chapters are how to find different aspects of a triangle. So things like perimeter and area and whatnot. So first of all, area, you may have learned this already, but the area, which we'll call A, big A, of any circle, circle Q, let's say, is equal to pi r squared. Now, pi is just a constant number. It's like 3.141592653588979. It goes on forever. It's what's called an irrational number, which means you can't divide one number into another number to get pi. You can't express it as a fraction. But pi you just keep constant, and r is the radius, okay? So this is general for any circle. Well, let's find what the area of this circle would be, circle Q. Well, let's just plug in. Area is equal to pi times 1 squared. Well, what's 1 squared? 1 squared is equal to 1 times 1, which is 1. So our area is simply 1 times pi, or pi. That's the area of this circle, pi. Now there's also something called a perimeter. Oh, an area, again, just to reiterate, area is just everything inside the circle that I've just highlighted in green, okay? Perimeter is if I were to walk around the outside of the circle, okay? If I were to walk around the outside and took a step on every point in the outside of the circle, what would that distance be? That's called the perimeter, and we call that big P. That formula is 2 pi r. So 2 pi times the radius. So again, always keep pi just itself. Don't call it 3.1415926. Just keep it as itself. Keep it pi. So you always express it in terms of pi. So the perimeter of this circle would be 2 pi r. So 2 times pi, we're going to leave it at 2 pi. But what's r? R is 1 inch, right? So then 2 pi r, 2 times 1 is 2. Our perimeter would be 2 pi for this circle. There it is. Okay. And so when would the perimeter and the area of a circle be the same? Well, that's interesting. Well, let's say if we just move pi over here for a second and we call this perimeter is equal to pi 2r. Well, then we'd say, okay, well, 2r, what if 2 and r were the same thing? Then 2r would equal r squared. Well, what would the r have to be in a circle where the perimeter and the area were the same? R would be 2, right? Because then r squared is the same thing as r times r, while 2r is the same thing as r times r. So 2 times 2 would have to be r squared, while r would have to be 2. So that's just an interesting thing that you may encounter later on, but that's the video on circles.